Hello, YouTube. We're here with a YouTube exclusive for you. We know that you love hearing about AI, and we have a great guest for you. Ali Farhadi is here. He's the CEO of the Allen Institute of AI, one of the world's leading research institutions that focuses on AI, has been for a very long time, even before this whole era of generative AI. Yes, they're one of the OGs, and they have a relatively new CEO. That's Ali, of course. And so, we were going to have a intro discussion just to get to know each other. And I thought, well, why don't we just put it on YouTube? So if you have any questions, feel free to drop them in the comments. And if you're watching afterwards, feel free to let us know what you think. If you like these, we'll do more of them here on the channel. And if you don't, then, totally understand. We'll just keep it to the podcast. But always trying to experiment here. And one last thing before we start, we hit a big milestone on the channel today, 4,000 subscribers. So it's amazing to see the amount of people that have signed up. Much of the growth has happened in the past year. I think we had about 1,000 a year and a year and a half ago, and so we've added 3,000 in the year. And it's great that you're all here, and we continue to go. So if you like the channel, please share it, let people know about it, and thank you for being here. So first of all, with that out of the way, I just want to say, Ali, it's great to see you. Welcome to the show.
Thank you, Alex. Excited to be here, and congrats on the growth. It's phenomenal.
Thank you. 4,000, it's modest, but the growth has been nice, and we definitely continue to see regulars here on the channel. So it's good to see a little community forming. First question for you is, just thinking about the way that AI is heading. It feels like we're kind of in this pause moment now, which is kind of funny to describe it as such. But we heard about all this innovation with LLMs, and then all of a sudden we have a lot of stuff on the horizon that people talk about, but isn't quite here yet. Right? Agents and, emotional type of sensing, robotics. So what do you think the state of AI is at the moment?
I would probably anchor that question in the context of the progress so far.
Right.
If you would have asked me 5 years ago where AI is, I would have never predicted today as is. So I think the pace of progress probably outpaced even our most radical expectations, or the most optimistic among us. A lot has happened. A lot of, in my opinion, breakthroughs happen in AI. We know a lot more than before. But also, there are roadblockers, there are challenges, and there are problems that we don't know how to solve them as a community.
Yeah.
So these are key characteristics of any kind of explorations. Like most scientific disciplines see these kinds of behavior. You see a rapid progress, and for a while you figure things out in another delta function. The challenge in AI, in my opinion, is actually sort of the amount of noise. And sifting through the noise is actually by itself is a hard problem. The momentum is huge. The pace of progress is, in my opinion, unsurpassed. But at the same time, there's so much noise around and so much hype that it's just hard to sift through. But all in all, I think natural and expected. I don't think we're stalled. I don't think we're blocked in the sense that no one knows what to do. There are hard problems. There's a lot at stake, and a good portion of Earth resources and talent and brain is actually being poured in this topic. So I'm sure we'll see more on this.
Okay, but so then answer the question though about the state of where we are. So there's progress, there's noise. All right, anyone could say that. So what do you actually think is happening?
Fair point. So where we are today is a mix of what we've learned so far. Right, we've learned the role of scale. To me, we've learned what you could squeeze out of abstractive, quote unquote, abstractive or textual knowledge from the web or from specialized sources. The models have exposed certain properties or certain capabilities that went beyond our expectation, in my opinion. Where we are today is we're in a situation where, probably for the first time, I might be wrong, our abilities to... Alex, did I lose you, or you just switched the screens?
Oh, no, I'm just making you more prominent.
I see.
Yeah.
So our ability to evaluate where we are has been slower than our ability to generate new capabilities. Partly because we are by surprise learning about new capabilities. The other part of it is these capabilities are of the form that we as a whole community are not comfortable with evaluating them. So to me, state today, I would call it actually, there's one part to it about evaluation crisis. There is no scientific evaluation about where things are. And the ones out there have major issues. And I think we need to fix that problem collectively as a community. We are in a situation where there are on a daily basis, if not maybe weekly, but most probably daily basis, people coming and say mine is better than yours. And here is one way to look at it, which is, again, there's so many problems with the evaluation piece. So evaluation crisis would be, to me, one problem that we're facing today. The other problem that we're facing today is sort of over the last couple of years, AI, which was a discipline, in my opinion, born and raised in open, suddenly practiced beyond closed doors. And I think we deployed a piece of technology that was not ready to be deployed. It's phenomenal. It's a breakthrough. It does amazing things. But I think we still need, there are technological gaps, there are research problems that we don't know. You alluded to some of those. And we deployed things at a phenomenal pace about a technology that's amazing, but not mature to be deployed. And as a result, Alex, you're muted if you're saying anything.
You're talking about large language models.
Large language model and generative AI technology in general, right? These are amazing pieces of technology. They're great breakthroughs. At the same time, we as a whole community don't know how to control them, how to control the output space of these models. And as a result, when we scale them and deploy them, interesting thing happens. We're learning about certain behaviors, and all of those things are great. But at the same time, we're also being warned, being surprised about certain things that we didn't like. So going back to your question, evaluation crisis is one piece.
Okay.
Being surprised in another piece. And the third piece is that acknowledging that these technologies have gaps, understanding those gaps, being able to work on them and solving them. So these, to me, are three pillars. And how do you fill in those gaps? We know one solution that has worked before, and that is open communal approaches to the problems. AI is today because we practice it in open. I built something, you build on top of my thing, someone else built on top of that, you came back again. And this has been absolutely the only way that AI progressed, with the exception of the last couple of years. And now, confining an immature piece of technology behind closed doors only hinders the pace of progress that we desperately need to get to AI from what it is today to a piece of technology that we could actually deploy at a scale with people being comfortable with it.
Yeah. So last week I wrote this story, our LLM's about to hit a wall. Just looking at the fact that there's been so much data and compute and energy that's been used in the most recent training of the models. Like we had Ahmed Aldala here on the channel, and he mentioned this, he's the head of generative AI for Meta. He mentioned that to train Llama 3 over Llama 2, which was like a 6 to 8 month process, they used 10 times more data and 100 times more compute. So doesn't this eventually slam into a resource constraint?
AI is getting more and more expensive, for sure. Playing in that playground requires more data, more parameters, and that means more compute. Does this mean that we're hitting a wall? I don't think so. I think we still have space to grow. Yes, it is expensive, but also I don't want to tie progress to increase in the number of parameters or the increase in the number of data points. Our models consume way more data than they should probably.
Why is that?
I want to say that again.
Why is that?
So again, let's go back to how these things evolved, right? There were transformers and attention-based models that came out, and we all got excited about it. People started scaling them up, and they realized that, oh, there's so much capacity to these models. Let me add more parameters to it. Let me add more data to it. Let me figure out a fine way to scale it. And suddenly, these new capabilities actually popped up. Then the common practice was, let me just scale more. Then we realized, if I want to scale more, oops, I need way more data. Where do I find data? And once we find data, oops, I need way more compute. Let me find more compute. And you see, there's been innovation and creative solutions in both of these spaces, right? We are actually sort of collecting, creating more data in the more creative way on a weekly basis. And people are coming up with more sophisticated, more innovative solutions on the compute front. You see a whole gamut of various different accelerators actually coming up. You see innovation on
Right.
how you deploy them at compiler level optimization, model level optimization, and all that jazz. And all of them are actually, I think, are healthy and natural and to some extent necessary for the progress as a field. The part that I was actually sort of pointing to is measuring progress for a piece of technology that we particularly don't know how to evaluate, and tying progress to the number of parameters or the number of data being digested is non-scientific. And I want to actually sort of cautious your audience about this. I generate my new many billion parameters, and I consume many X more data, and I show improvements on some of these benchmarks. Some of them are saturated, some of them have been leaked, some of them actually do not actually correlate with the end capabilities that we want. Some of them might be a good evaluation. So I think we're in a space where we don't know deep down what better means, because we don't know how to scientifically evaluate them. And as a result, we need to sort of go back to some understandable notion of metrics so people can actually get excited about it. And remember, this is actually an environment where people need to, at least big entities, need to play a very careful game. They need to stay on top. They need to actually stay relevant. What we end up seeing is actually sort of a competition for more number of parameters, more number of data points. Both of them are actually necessary, and some improvements over benchmark data. Is this the only way forward? I don't think so. Have we squeezed? Yeah, have we squeezed all we could have squeezed on the existing amount of data? We don't know yet. Are the loss functions that we're actually using today, I mean, next token prediction, is that the only thing that we need to do? We still don't know. There's a lot to be explored, in my opinion. And there are a lot of design decisions that we as a whole community make in designing these complex language models. And many of those design decisions, we're either inheriting them from someone else, or we run some set of ablations, some set of experimentations. But we only cover a small fraction of those parameters. And the space of the design space of these complex systems are heavily unexplored. And remember, any of those explorations are really expensive.
Because
you have to actually define a set of parameters, train a model under those set of parameters, look at your result, and then decide if these parameters are good or bad.
And how much does that cost each time you do it?
It's a lot. It's very expensive. It really depends on how many billions of parameters you have. What data are you using it? Are you renting it in the cloud, or you have your own infrastructure? It varies. But if you're actually sort of doing 7 billion models, it's $5 to $10 million.
Wow. Okay.
It is expensive.
Yeah.
Some people are more efficient at it. Some people are less efficient at it. But any combination of these parameters are expensive to evaluate. But also, these parameters are combinatorially related. If I change parameter number 1 to a value and change parameter 2 to something else, can I go back and actually redo this thing? So my argument is that the design space, I don't know if you hear it.
That's a seaplane in Lake Union.
That is exactly. That's a seaplane. Let me pause for 1 second for the plane to pass.
Keep going. Yeah, you can keep going through it. We can hear you fine.
So the design parameter, the design space of these models is A, complex. B, is governed by a large number of parameters. And figuring out those parameters is expensive. People have been creative on scales of law and how can actually a law of scale, and how could you actually learn from a smaller model and extrapolate it to the behavior of a bigger model. All of them are very valuable, but still there's a lot to be done. So I probably disagree with the notion that we're now the whole progress stalled. No, there's a lot to be done.
It's all about optimization at the moment. So is that what you're saying?
Say that again.
It's all about optimization.
It's about learning more about these systems we know very little
Yeah.
about. Right.
It's
One
kind of
aspect.
encouraging that it's so early on, I guess, and they're already this powerful in the most crudest ways of training them.
This is phenomenal. Yes, they're powerful. We know
Mhm.
very little about them. I use the word surprise. We are surprised by certain
Mhm.
behaviors of these models when we don't
Mhm.
truly understand what's happening. One aspect is more parameters, more data, and people are heavily exploring that dimension, and that's great. We should. Other aspects is questioning our design decisions. The other aspect
Mhm.
is questioning our parameter choices, our loss functions, and all of them are yet to be explored. If I want to speculate, and I've been wrong about my speculations, I
Mhm.
think we are not squeezing all we need to squeeze from the current number of parameters and the current
Mhm.
number of data points that we have.
Yeah.
What is the
S-
form of the solution yet to be known?
Right. So what are you working on? What is I mean, let me give you my impression of Allen Institute of AI, and you tell me if I'm wrong and sort of where you're heading. And by the way, folks, if you're watching live right now with us, I've seen some folks checking in. Feel free to drop some questions in for Ali Farhadi, the CEO of Allen Institute of AI, one of the leading research houses in AI, long time going. So um, you're a nonprofit, right?
We
So
are
do
a
you?
non-profit kind of non-profit.
Okay. So I'm unlike OpenAI. Is that what you're poking at? Yeah. So let me ask you then. So what are you working on, and how do you sort of yeah? How do you compete today in a world where funds are so important?
Those are great questions and sort of great challenges for us. So
Mm-hmm.
the position that we have today is we don't feel like we have to compete.
Mm-hmm.
Our mission is rather clear. We are after scientific progress
Right.
and after deep understanding of what's happening in within these models. Um, our philosophy has been anchored around openness and true openness. So openness is an overloaded term these days,
Mm-hmm.
right? You've seen the space. I train a model behind closed door. I don't tell you what I did. Um, but after I'm done, I'm gonna toss the model over the fence with the right licensing so you could use it. That's great, actually. We love it. This has sort of bootstrapped the rate of progress, but it's not enough without people understanding the whole pipeline. And the most important piece of this pipeline, and we're learning as we talk about, is data.
Mm-hmm.
Data rules this game. Data makes it, also data breaks it. Data is the one that causes legal conversations, policy conversations, alignment conversations. So the data is a root cause of many of these problems or benefits, and yet we're being hush hush about it and being very quiet about it. Scientifically impossible to evaluate these models without actually opening up the data. Scientifically, it's hard to build upon these models without knowing the whole gamut, the whole pipeline. So one of the things that we're after these days is true openness, which means let's open up every piece of the pipeline.
Mm-hmm.
We started by opening up data. Dolma was the very first version of the data we released a while back. It was 3 trillion tokens of open training data. People have started doing phenomenal things with them, incorporating them. We'll love to see the adoption. After that, we released our almost 7B models. These are the smaller side of models that are fully open.
Mm-hmm.
The training data is open. The training algorithms are open. What we did with the data, how we collected it, how we cleaned it is open. But also the logs are open and all the checkpoints are open. And that's actually extremely valuable in my opinion because you get to see what happened to the model after we changed few parameters during the training. That to me is actually us getting closer and closer to quote unquote open source approach to software development. Because
Mm-hmm.
to me, open source means that I could grab the piece of software that you wrote, fork it, and do what I want to do with it. But with partially open models or models that are trained behind closed doors, I don't have actually access to those checkpoints. I don't know what the algorithm was. I don't know what the data was. It's actually hard for me to build upon it without me guessing about what was happening behind the closed doors.
So are you guys all in on large language models now?
We spend a lot of our energy and time on actually making these components in this whole pipeline open, so
Mhm.
scientists, researchers,
Mhm.
developers, engineers could look into this, build upon it,
Mhm.
and make progress in that space. And we're releasing our artifacts as we get our hands on them. We train them, we work on them, and we release them. We are a research institute. We have a few hundred of the top researchers, engineers in the world working on
Yeah.
these kind of problems. And obviously, our job is to innovate in that space, and that's what we're after, by building the building blocks that is necessary for the innovation.
Yeah.
We also take the position that there's a lot to be on that we don't know about these models. Contrary
Mhm.
to these problems are solved, and the combination of those three letters A, G, and I together,
Mhm.
where this is actually going to replace human intelligence. We don't believe in those directions. We
Right.
believe in this has been great progress, a lot to be unknown, a lot to be discovered and innovated, and we're right after that.
Yeah. Awesome, Ali. Well, look, I hope we can keep in touch. And I love speaking with people at the Allen Institute whenever I have a question about AI. So I hope to keep the tradition up with you as the leader. And it's great to meet you. And congrats on taking the helm.
Absolutely, Alex. It was great talking to you.
You too.
And this is a great show and great podcast. Keep
Thank
it
you
coming.
so much. Really appreciate it. Thanks, everybody, for watching. Thanks again, Ali, for being here. And we'll be back later this week with a lot more stuff. So stay tuned.